Hello, we're Group 2, and our project is called Dowsing Cane.
So the basic overview of our project is it's a white cane, a cane for the visually impaired that Bluetooths with an Android device, and a corresponding Android app sends directions via Bluetooth to the cane to direct the user from point A to point B.
So these are the final design components that we decided to use. We tested out some other ones, but we decided to go with these ones because they work best with each other. We have the lily pad, the Bluetooth module, the motors, regulator circuit, and then on the software end we have the Android application and the lily pad firmware.
So our original design, we were going to use this Motorola Makerphone. And so the Motorola Makerphone is essentially an Android phone that has an Arduino literally slapped to the back of it with some glue and connected serially to the device. So there would be a serial connection. And we thought that that would be a really good development tool to use. We were also going to use text-to-speech for most of the application. So in addition to the vibrational impulses, there would basically be text-to-speech indications, so like turn left at X. On top of that, we were also going to use an Arduino Micro originally. So out of this design, what worked? So guidance from point A to point B worked. That was something that worked pretty well. It was pretty consistently well in terms of working. So what we used to do this, we used the J.D. Alexander routing library, which is an open source routing library on GitHub, as well as the Google Maps and location API. But those are just a small fragment of the APIs that we used in the long term. In terms of the physical cane, the haptic feedback, so the vibration motors and the vibration motor pulses, those worked. They were both, they were all very individual in terms of the different indicators, so you could tell them apart. And the physical design, we used silicone molding for the cane's handle, and then we covered it with a wire mesh in the final product. So
some things that didn't work out so well for us. We started development with an Arduino Uno, and we got the Bluetooth communication working on that. And so we were ready to switch over to the Arduino Micro because it would be a smaller unit. And we found out that the Bluetooth communication didn't work so well with it. And that's when we decided to switch over to the lily pad. And for the routing, whenever you first start, you hook onto a Wi-Fi router and you start moving away from it. It'll think that you're closer to the Wi-Fi router than what you actually are.
With our original design, going back to that, we realized that there were some faults with it. With the Motorola Makerphone, it just didn't really make sense because we were trying to create a Bluetooth application that connected from the Android phone to the cane using a Bluetooth connection. So having a physical serial connection that used a special API just wasn't the right way to go with that. And then to talk about the text-to-speech mode that we were going to use, it just didn't really make sense to have all of the different directions be verbally announced as well, because when we spoke to our visually impaired advisor, they said basically that Google Maps and all those different mapping services already have text-to-speech options where it will tell them when to go, where to go with an audio output. But the whole point of ours is to have a vibrational direction indicator rather than audio. So it just didn't really make sense, so we scraped that idea, and that's...
So for the second iteration of our design, like we said, we switched from the Micro to the lily pad. This is mainly because they're in the same family, but the lily pad was built around, or is built to function with the Bluetooth module. And you can actually see it has these 6 serial pins on the board that you can directly plug the Bluetooth module into. It's also smaller than the Arduino, or yeah, smaller than the Uno, which makes more sense for a project. Yes. The hardware that we built was fairly simple. So our power source was a 6-volt battery pack, and this is too high of a voltage to power the lily pad safely with. So we built an LM350 voltage regulator circuit that brought the voltage down to a safer 4 volts. And then that 6-volt pack also was directly connected to the motors, allowing us, as well as TIP 120 transistors, which allowed us to toggle the motors through the lily pad.
So for the software, essentially the core of it was an Android application. The Android application was, in its essence, a turn-by-turn directional indicator. So basically the user would turn on their phone, they would open the application, they would then press the down volume button for about 3 seconds on their phone. Then the phone would open up a voice input module using Google Voice. The user would then state their address, for instance, 125 North Madison Street, Iowa City, which is the IMU. And then it would route them from their current location to the IMU using walking routing patterns. And then basically, going back to that, what would happen is that it would indicate at different points and send that signal to the cane, and then those signals would indicate to the user that they need to do shifts at different points. But why Android? Why would we use Android for this platform when there's Windows Phone, there's iPhone, the iOS development, there's a bunch of different development suites for phones that we could have used? Well, Android's pretty robust, it's pretty accessible to students such as ourselves, and it's used by a very large amount of users. It has a very large user base, and that makes it more, I guess, valuable to us in terms of having documentation, having different various examples of functions, implementations of APIs. So because of this, it was a pretty easy choice. And on top of that, I already had Android experience, so it was kind of like the icing to the cake that it would be somewhat simple to do. So we had a bunch of APIs that we used. However, if we listed them all here, it wouldn't fit the slide, and that's probably not a good thing. So I listed the top APIs that I used. So I used Google Android Maps for the developer version, if I would call it that, because in the final version, what we intend, if we were to work on this further, would be to make it so that it ran in the background of the phone rather than as a main application. Because of time constraints, that wasn't really a feasible thing. So we use the Google Android Maps API, the Places API, the Locations API, which reflected the user's current location and did a lot of functions and had a lot of functions pertaining to the user's current location and other location points in terms of latitude and longitude points. And then we also used the J.D. Alexander routing API. And then a bunch that I didn't think that we would need to use, but since Google likes having their developer console, we implemented them anyway.
Okay, as far as user application interaction goes, there are two main pieces to this project. There's the cane. The user interacts with, basically the cane leads you where you want to go through the vibration patterns. You have short, long, short for forward, long, short, long for backwards, etc. The user can also use the buttons on the phone to interact with the application through, we use the volume up and volume down buttons to call functions. Volume up allows the user to replay the last direction that was sent to the cane. So if they missed it, something was distracting them, they can find it, they can find out what they missed. And then the volume down button allows the user to find a new destination at any point, regardless of whether they're currently being routed or not.
So the routing in the application. So Google Maps doesn't really have a routing API for us to use. They don't really have anything other than a web service that we can call functions from. So in the Android development environment, what we needed was a open source alternative, so that we didn't have to implement all of this code that has been implemented 1,000 times before. So we found this open source routing library by J.D. Alexander on GitHub. So it's a great library. It works for a very, very vast majority of the time. However, there is a small error that we found later in the process, in that if it doesn't make the proper calls and if it doesn't finish its functions correctly, it becomes buggy for the rest of the application's life. So essentially what would happen is, if it failed, then I would literally need to restart the phone to do it. This would obviously be something that we would address upon working on it more. For instance, I would create my own implementation, but since it was so late into the process, it just wasn't very feasible for us to fix this error. So the different directional inputs and the directional indications were done having multiple types of notifications. So there was the weak notification, which was at 40 meters away from the next point. A strong notification, which was at 15 meters away from the next point, and then a constant notification, which was used specifically for at final destination and and if the phone disconnected from the cane. So using these different notifications, we also had another that was used that was more of a strong, if I believe. Whenever it would start rerouting, it would have a notification going to the cane, and the rerouting would occur when it went 30 meters away from any point on the line. And it would reroute directly to the user's original destination that they wanted. So if the user went left when they were supposed to go straight, after 30 meters of going left and going straight after going left, it would reroute to their original destination. However, since it's dependent on the routing API that was found to be buggy every so often, it sometimes messes up because of that. So this is some examples of the application in its current state. The first view is obviously just a simple map. That's what it opens up to, and then it centers in on the user's current location. Then they can input an address, as you can see here. Well, not really, because it's not very, it doesn't really stand out well because it's white. It says Washington Street in Iowa City. So essentially, you're trying to find Washington Street from your current location. So it routed from their first point, which is here, to Washington Street, which I assume is off the map and down that way. It says within range of change right now. So right now, that means it's within 15 meters. And because it's within 15 meters, it's going to send a strong indicator to the user that tells them that they're going to need to turn right here. And here's just another example of it directing them and showing them where to turn.
So for the Bluetooth communication, we have the RN42 connected serially to the lily pad. And the lily pad opens up a serial connection at a baud rate that works with the Android phone. And then on the Android phone, we have it so that the Bluetooth is checked whenever it first launches to make sure that it's running. And then it'll try connecting to the lily pad. And once it connects, it'll also periodically check whenever it sends a command to make sure that it's still connected. And so in conclusion, we have a working version of our product. It guides a person from point A to point B, and it does that through the use of vibrational pulses.
Thank you.
Okay, so I have a question about